Hi students, now we are going to discuss a beta decay process. There are two types of beta particles, namely beta minus and beta plus. Beta minus particle is nothing but an electron and beta plus particle is nothing but a positron. Positron is an antiparticle for an electron because it has a mass equal to that of the electron, but it has a positive charge while the electron is having a negative charge. Now first we will discuss what is beta minus decay, during which an electron is emitted by the parent nucleus. So as usual, I will consider a parent nucleus X whose charge number is Z and mass number is A. So during this beta minus decay, it emits an electron, that is a beta minus particle. As a result, a daughter nucleus Y is formed. Along with this, an electron whose charge number is -1 and mass number 0 is released. So along with this, antineutrino is also coming out. This new bar is called an antineutrino, which is an antiparticle of a neutrino. This neutrino and antineutrinos, they do not have any charge. They have very small, negligibly small mass. So this is the decay scheme for beta minus decay, during which an electron is emitted. Now we have heard that an electron does not pre-exist inside the nucleus. The nucleus contains only the neutrons and protons. Then from where this electron is coming out? If there is no electron inside the nucleus, how is it possible? It is because during the beta minus decay, an electron is produced due to the splitting up of a neutron into a proton and an electron. So this is possible because a neutron is splitting into a proton and an electron. So this is an electron. Along with this, this anti-neutrino is also released. Okay students, so this electron is just produced during the radioactivity only. Okay students, now you see that the electron is having a charge number of -1 and mass number of 0. Because of the leaving of an electron, what change does the nucleus undergo? Let us see. So what should be the charge number of the daughter nucleus? Must be equal to Z minus of -1. So this is Z minus of -1 is +1. And A minus 0 is A itself. So what are all the changes the nucleus is undergoing? You see that the charge number has increased by 1, the mass number does not change, the neutron number decreases by 1 and the proton number increases by 1. So this is a summary of the beta decay, that is the beta minus decay or electron decay process. So one example I can give for this. So what is the best example for this is, I will take carbon. Carbon is having a atomic number 6. One isotope is having a mass number of 14. So carbon 614 isotope I will take as the parent nucleus and it emits a beta minus particle. So during which nitrogen is being formed plus E minus electron plus antineutrino. So this is the antineutrino. Now what must be the charge number and mass number of nitrogen? It is 6 minus of -1. So 6 plus 1 is 7 and 14 minus 0. So this must be 14. So this is the example for beta minus decay. Now second type of beta decay process is beta plus decay. So here we are going to discuss now beta plus decay. During this decay, what particle is emitted by the nucleus is a positron. So positron. This is a beta plus decay. So here also X is the parent nucleus having a charge number Z and a mass number A. Now it is emitting a beta plus particle. So this is a beta plus particle, during which a daughter nucleus Y is formed. Plus A positron is denoted by E plus 1 0. So this is E plus 1 0. This is a plus 1. Along with this, a particle namely neutrino is emitted. Now we will balance the charge number. Since this positron is having a positive charge of 1 unit, because of its leaving the nucleus, the new charge number of the daughter nucleus must be Z minus 1. Z minus 1. And the mass number remains the same. So, what is the reason for this leaving of a positron? From where this positron is coming out, the nucleus does not having a pre-existence of this positron. That means it must be created just during this emission process. So it was found that a proton is split. A proton is now split into a neutron and a positron. So this is E10 plus this neutrino. So during this beta plus decay process, the proton number decreases by 1. So when the proton number decreases by 1, the charge number is decreasing by 1. But to compensate this loss of proton, one neutron number is increased so that the mass number remains the same. So the best example for this we can take the sodium nucleus. So this is a sodium nucleus. One isotope of sodium, radioactive isotope of sodium is 1122. So these are all radioactive nuclei. Okay. So this is emitting a beta plus particle, namely a positron. So after emission, it becomes a neon plus this positron E plus a neutrino. Now you can tell me what is the charge number of the neon must be. It is Z minus 1 means 11 minus 1 is equal to 10. Similarly, mass number does not undergo any change means it is also having the same mass number 22. So my dear students, what is the summary of the beta decay? What are all the changes taking place in the parent nucleus during the beta minus decay? The charge number increases by 1, mass number remains the same, neutron number decreases by 1 and the proton number increases by 1. And here during a beta plus decay, the charge number decreases by 1, mass number remains the same, proton number decreases by 1 and the neutron number increases by 1. Have you all understood? Okay, fine.